Okay, I ask you to pause the video and read this problem. While it's paused, see if you can come up with the null hypothesis and the alternative hypothesis on your own, but we will talk about that. So I don't want to say that these first sentences are irrelevant, but I think it might be misleading because this specific machine wants the mean to be 20.1 grams. So that's what's going in the null hypothesis, is that it is 20.1 grams. And I also don't want to read above in terms of the alternative hypothesis. So they're just concerned about the calibration. They just want to know if the machine is going to produce these candies to be 20.1 grams. So the null hypothesis is that, or the alternative hypothesis rather, is that the mean is not 20.1, either too high or too low. So I'm going to use the data from the table. So I'm going to go to stat, and I'm going to go to tests, and I'm going to go to t-test, and I need data from a table. So I'm actually going to exit out of that, go to stat, go to edit, and input this data into my L1. So 19.68, maybe you can fast forward me, or you can type in as I'm going, but just make sure that you type in the data correctly. So yeah, if you want to subscribe to my YouTube channel, I would appreciate it. I'll give you a bonus point if you subscribe to my YouTube channel. Okay, so it's always good to make sure that you type in them all correctly. Okay, excellent. So I'm going to exit out of that. Stat, tests, t-test. I do want data, and so I do need to change the mean from the null is 20.1. I want the list to be L1, the frequency to be 1. My calendar. Okay, then I'm going to go over into, I want not equal to, and then again, calculate or draw will give you the same p-value. I just like drawing it because I like seeing the picture, but either one works just fine for our cases. So the p-value is 0.3226. So I'm going to compare the p-value of 0.3226 to alpha, which is 0.01. And so since it's greater, do you remember what we do? We will not reject. And not rejecting the null hypothesis, or not, yes, means that there is not enough evidence to conclude the alternative hypothesis. So there is not enough evidence to conclude that the mean candy weight is something other than 20.1. Oops. And then they talk about statistical significance versus practical significance. So there being a difference, statistically speaking, it can exist, but then you have to analyze in practicality, what does that mean? So maybe read number 3, definitely read number 3, see if you can come up with the null and the alternative hypotheses, see if you can do the whole problem while you're at it, and then we'll check in. Okay, so they say they reprogrammed all these traffic lights and they adjusted the data. And so the null hypothesis was that the mean was 27.3 if nothing changed. And they want to know if the travel time decreased. So if it was less than 27.3. So I'm going to go to stat, I'm going to go to tests, I'm going to go to t-test, I'm going to go over to stats because this is the data that they give me. So my mean from my null is 27.3. In the problem, they find a sample mean of 27 and a sample standard deviation of 8.5. So sample mean is 27, 8.5. So did I just get lucky and pick, 2,500 commuters whose time went down, or is there actually a difference here? So the sample size is 2,500, and I want to know if it went down. So I'm going to draw, and I'm going to see what we got here. So the p-value is 0.0389. So let's compare 0.0389 to 0.005. Oh, 0.05. And so it is less than, and so if it's less, we reject the null hypothesis. So rejecting the null hypothesis is interpreted as there is enough evidence to accept the claim that the mean travel time has gone down. And so this paragraph just talks about, while there is a difference between 27.0 and 27.3, so it is statistically significant, there's no practical meaning. After all, if it took you 0.3 minutes or 18 seconds less to get to school or work or whatever, is that really significant? And they're suggesting maybe not, but statistically it is different.